Hi, and good evening. So, continuing on, this is just the last lesson in Unit 3, and like I explained yesterday or in the last video, um, it didn't fit in very well with the previous sections of this unit. So we decided to make it its own small short unit. So you'll do its quiz um, maybe tomorrow, Wednesday or Thursday, depending on how easy this homework was for you. So we start by talking about direct variation, and the idea today what we're looking at is how we can model different situations using variation. And we'll start that with direct variation. Some words that you've had used before relating to this idea is proportion, direct proportion or inverse proportion, and I cannot believe, I think we can all agree that we've heard about proportions before. So that's just what we're talking about today. Proportion is the same thing as variation. If x and y are related by an equation of the form y is equal to kx to the power n, then the relationship is direct variation, or as you say, direct proportion. The constant k, or the item k, is called the constant of variation. Let's look at an example. If I have a constant that's varying directly with the cube of x, right? Then if y is 25, x is 2, find y when x is 6. If something is varying directly with the cube of x, then something is varying directly with the cube of x, y is directly proportional to x cubed. This is like the basic interpretation of that statement, but we will skip this stage in the future. But just so you see that if you ever see this fish anywhere in your life, it just means direct proportion or variation. We'll jump straight and use the formula, because the next step after dealing with the fish is you remove the fish and then you just replace the fish with a constant of variation. So that's what we're doing here. That the formula we're using is y is equal to kx to the power n, kx to the power n, and if it is direct variation, since this question is direct variation, then our y is equal to kx to the power n will become y is equal to kx to the power 3, because they told us that the power is a cube. Now, they've given us some information. If y is 25, x is 2. That is like boundary information or initial values. In physics, we call that boundary conditions or initial conditions. And those help us to find the value of the constant of proportion. So they said y is 25 and x is 2, right? So I have 25 is equal to 8k, and when I solve that, I have k is equal to 25 out of 8. Now I can rewrite my variation or proportionality equation as y is equal to 25 out of 8 x cubed. Now that I have an equation relating x and y, I have this variation equation for x and y, I can easily solve for this. I can easily find y when x is 6. I'll just say y is equal to 25 out of 8 times 6 to the power 3, and you substitute that and you find the value of y. Alright, they need me to find an equation that describes the relationship when y varies directly with x. So if it's varying directly with x, I know my equation will be of this form, kx to the power n, right? So it's not saying it's varying with x to any power, it's just varying directly with x. So my equation will simply be y is equal to kx. I hope you can see that clearly. And then I'm going to use the boundary conditions given. I'm going to use the initial conditions given to find the value of k. So the initial conditions say that when y is 12, k is 6. So, when y is 12, x is 6. So that is 12 is equal to 6k, so that means my k is equal to 2. So that means that my variation equation is y is equal to 2x, right? And if I'm going too fast, you can slow down this video. But these ideas you covered in 9th grade, you covered in even 8th grade. So yeah, if I'm going too fast, slow down the video or let me know. So this is my variation equation, and that's what the question asked for, so we're good. Next one is inverse variation. Inverse variation, if they are related by an equation of the form y is equal to k out of x to the power n. And like I was saying earlier about the fish, the raw interpretation of this would be y is equal to, y is proportional, because this symbol means proportional, 1 out of x to the power n. But when you get rid of that fish, that proportionality sign, then you have the proportionality constant. So this is where we'll jump to straight away. This fish is just for exposure, but that's what we'll jump to straight away. The quantity y varies inversely with the cube of x. So I know that my equation has to look like this because it's inverse proportion. So if I substitute what I know, y is varying inversely with the cube of x, so that's what I substitute. And then I'm told that y is 25 when x is 2. So 25 is equal to k divided by 2 to the power 3. So that means my k value will be equal to 25 times 8, because 2 to the power 3 is 8, and because when you cross multiply, you have 25 times 8. So I think that's 200, right? So your k value is 200, and now you can write your variation equation. Instead of writing y is equal to k out of x to the power 3, your equation is nicely y is equal to 200 divided by x to the power 3. So now they're asking you to find y when x is 6. That's simple. I'll just substitute for x as 6 to the power 3, and I trust that you guys can use your calculators to simplify that. The next idea is joint variation. That's when a variable varies directly or inversely with more than one variable, with multiple variables. So if x varies directly with both y and z, then you just have the same equation we had earlier, because earlier it was y is equal to kx, but here you just continue writing as many variables as it is varying directly with. If for example y is varying directly with x, y, z, a, b, c, you just write them as many as possible, multiplied, right? Product, not added. So this is what that looks like. And if it's varying inversely, let's say x varies directly with y, so then you would write ky on top, and it's varying inversely with z, then you would write z at the bottom. I'm going to show this better in the next slide. So however, we need to know that we only use one constant in a joint variation equation. Let me just explain this a little bit. Let's say you have y is varying directly with x, and you also have the same y is varying inversely with, say, x squared, or maybe m squared, right? It's varying inversely with m squared. Now this is the same quantity y, right? And it's varying in two different ways, directly and inversely with different quantities. So when I get rid of the fish, I'll have y is equal to kx, and when I get rid of the fish here, I'll have y is equal to k out of m squared, right? Or before I get to that stage, if this y is varying directly with x and the same y is varying inversely with m squared, then I can write this as y is varying directly with x and inversely with m squared. I have combined the variability of this variable y. And then finally, I can get rid of this proportionality symbol by introducing a proportionality constant. So that will be kx divided by m squared. This is what's going on in this slide over here, right? If it's varying directly with with y, that's ky, and inversely with z, then you have z at the bottom. So let's look at an example. This quantity is varying directly with the square of y and inversely with the cube root of z. So if it just listening to that statement, it's varying directly with the square of y. The quantity is x. X is varying directly with the square of y, and inversely with the cube root of z. I'm just naturally writing this fish, but you can just go straight to this stage where you write the proportionality constant, cube root of z, and this is your equation. Then you use the boundary conditions to find the value of k. The boundary conditions say x is 6, y is 2, so that's 2 squared, and z is 8, so that's the cube root of 8. So if I solve for that, I'll have 6 is equal to 4k divided by 2, which 6 is equal to 2k, which k is equal to 3. So then my equation written properly will just be y is equal to 3y squared divided by the cube root of z. And then I can use that equation to find x when I'm given these values, right? So my equation does not start with y, it starts with x. I don't know what I ate this morning. Okay, it starts with x, so sorry about that. It starts with, yeah, this should be x, and then this is y. Yeah. Alright, so they want me to find x when y is 1, so 3 times 1 squared divided by the cube root of z is 27. I trust you guys to be able to finish that. Write an equation describing the relationship of the given variables. Y varies jointly with the square of x and the square of z when x is equal to 3 and z is equal to 4, then y is equal to 72. So first think for a second, this is not telling us it's varying directly or inversely, it's just telling us it's varying jointly. So when you come across something like that, how do you interpret it? How do you interpret that joint variation? Well, if you are not told explicitly that it's varying inversely, this statement varies jointly, then you can consider this to be a direct variation. So it says that y varies jointly with the square of x and the square of z, right? So when I remove the fish, please, like I said earlier, I just use the fish to go back to the basic definition, but you can always just skip ahead and start here. Y is equal to kx squared z squared. The boundary conditions are when x is 3, z is 4, then y is 72. So I use those boundary conditions or initial conditions to find the value of k. So that's k times 3 squared times 4 squared. So I have 72 is equal to 3 squared is 9, 4 squared is 16. 9 times 16 is a big number. What's 9 times 16? Half. 9 times 16. 144. Yay. 44k. Alright, divide by 144. Divide by 144. So k is equal to, anyone? Divide by 72. K is equal to a half. Alright, so my equation, I can write my equation as y is equal to half x squared z squared. And that's what they asked me to do, to write an equation, so I'm done. Yeah, so this is your homework, and we'll go over this in class tomorrow. Bye.